Imagine, imagine handing a complete stranger the master keys to your corporate network, setting a timer for 30 minutes, and then just walking away.
Yeah, that sounds like an absolute nightmare.
Right. But in the world of enterprise cybersecurity, we do this thousands of times a day. We call it programmatic API access.
Exactly. And if you don't understand the exact blast radius of those automated 30-minute windows, you don't just fail a routine audit. You you potentially compromise your entire infrastructure.
Completely. And for everyone listening right now, you already know the stakes here. You are prepping for the CrowdStrike Certified Falcon Administrator exam, the CCFA.
Yep, a big one.
And you understand that hunting advanced persistent threats, that's the high visibility work. That's the glamorous stuff.
That gets you in the news, right?
Exactly. But user management, which is the core focus of our deep dive today, that is the architectural bedrock. It literally dictates the boundaries of reality within the Falcon console.
It really does. It's the keys to the kingdom.
And the CCFA, it's a 90-minute, 60-question gauntlet. It demands absolute granular mastery of this specific domain. You cannot just guess your way through role-based access control when there's a $250 exam fee on the line.
No, you really can't. The exam actively tests your ability to architect defense in depth from the inside out.
Right.
We are tackling 3 highly testable objectives today, and we're pulling this strictly from the official documentation, the exam guides, API integration manuals, all of it.
The dry stuff, but we're going to make it stick.
Exactly. So you need to know how to determine the required roles for console access, how to create custom roles based on really precise, effective permissions, and how to manage API clients.
And we should warn them, the exam writers are deliberately looking to expose, surface-level understanding.
Oh, absolutely. They love a good trap. They will present scenarios where the most obvious answer is completely wrong.
So let's start with Section 1. I'm looking at the documentation on predefined roles, and I really want to push past the basic definitions here. We have the standard 4, right? Administrator, analyst, real-time responder, and read-only.
The foundational blocks, yeah.
Yeah, and on the surface, it's really tempting to use a museum analogy here to understand them.
Okay, museum. I like that.
Right, so the administrator is the museum director with the master keys to every room. The analyst is the curator, walking around with a flashlight. They can examine the artifacts closely, but they can't actually move them.
Right, they can look but don't touch.
Exactly. Then the real-time responder, that's the armed security guard who can actually physically tackle an intruder if they have to. And read-only is just, a tourist standing behind a velvet rope.
That's a great mental model for a quick baseline. But we need to translate that into actual platform architecture for the exam, because the exam isn't going to test you on museum logic.
Right, unfortunately.
It's going to test the underlying JSON policy structures and the HTTP methods assigned to those specific roles.
Okay, so let's break that down. If your curator, so the analyst, tries to interact with a host group configuration, what actually happens on the back end?
Well, the documentation is really clear here. The analyst role is granted get requests for detection and host data endpoints.
Just get requests.
Right, just get, but post, putty, and delete requests for configuration endpoints are strictly blocked.
So they can't change anything.
Precisely. If they try to somehow bypass the UI and hit the API endpoint to modify a host group, the platform just returns a 403 forbidden error.
Hard stop.
Hard stop. The predefined roles in Falcon map directly to Standard Security Operations Center tiering, and that's to ensure immediate compliance with the principle of least privilege.
So a Tier 1 analyst doing initial triage is assigned the analyst role because their job function just requires reading telemetry and writing comments to an incident log.
Exactly. If you assign them the administrator role just to make things easier, you've introduced catastrophic risk to the environment.
But let me play devil's advocate here. I'm looking at a deployment scenario for a massive global enterprise. We're talking 50,000 endpoints, a 3-tier SOC spanning 4 time zones, and a huge influx of new hires.
A very standard enterprise mess, yeah.
Right. And the documentation heavily emphasizes using these predefined roles for quick onboarding rather than building from scratch. But if I'm a security architect, why shouldn't I just build highly customized roles from day one to ensure absolute granular control? Doesn't that make more sense?
You'd think so, but customized complexity scales incredibly poorly during initial deployment.
Oh, interesting.
Yeah, CrowdStrike actually designed these predefined roles to cover, I'd say, 90% of standard operational workflows right out of the box.
So it's about efficiency.
Pure efficiency.
Yeah.
Building custom roles from scratch for every single analyst requires extensive mapping of hundreds of individual micro-permissions. It's a nightmare.
I can imagine.
By defaulting to the predefined analyst or real-time responder roles, you establish this baseline of auditable, standardized access. You eliminate the friction of deployment while still enforcing least privilege.
So for the exam, they might ask about this.
Oh, the exam will frequently test this by asking for the most efficient way to grant access to a specific job function. And usually the predefined role is the right answer for general tasks.
Got it. Which brings up the real-time responder role, actually. The documentation splits RTR into different levels of access. A standard analyst can't just, open a remote shell on a domain controller.
Right, and the CCFA requires you to understand the distinction there between active remediation and passive analysis.
Active versus passive.
Exactly. The real-time responder role grants the ability to establish an interactive session with the Falcon sensor on a host.
So from an architectural standpoint, that means the user can execute commands via the cloud right through the agent directly onto the operating system.
You got it. They can kill processes, retrieve files, execute basic scripts. It's incredibly powerful, which is why it's segmented away from the standard analyst role.
Okay, so predefined roles are the foundation. But the exam traps, and I mean the really tricky ones, those are buried in the module-specific roles.
Oh yeah, Section 2, navigating the nuances. This is where people fail.
Because Falcon encompasses firewall management, identity protection, next-gen SIEM, and each of those modules introduces its own highly specific RBAC requirements.
Yep, it fragments.
So let's look at firewall management because the documentation presents a scenario here that feels, to be honest, entirely counterintuitive.
You're talking about the firewall manager role.
Yes, right. So to create and edit firewall rules or assign rule groups to policies and assign policies to host groups, the documentation says you must hold the firewall manager role.
Sounds straightforward so far.
Right, but the explicit fine print states that the firewall manager role does not include the ability to create and edit the host groups themselves. You have to bring in a full Falcon administrator just for that.
It does seem weird at first glance, right?
Yeah.
Why give them the keys to the firewall but not the groups?
It's like having a driver's license, but not having the keys to the specific car. If I'm a firewall manager and I write a brilliant new network rule, why did CrowdStrike intentionally design the system so I can't apply it to a host group myself?
Let's examine the blast radius of a host group to really understand why the platform is engineered this way. A host group in Falcon, it's not merely an organizational folder.
It's not just a tag.
Exactly. It is the structural nexus for prevention policies, sensor update schedules, and role-based access scoping.
Oh, wow. Okay, so if a firewall manager realizes a specific subnet needs a highly restrictive network rule, and they just go and create a new host group to apply that rule.
They might inadvertently strip those exact hosts of their primary malware prevention policy.
Wait, really? Just by moving them?
Just by moving them.
Yeah.
Because if a network specialist creates a new host group and drops a critical database server into it just to apply a port blocking rule, that server now inherits whatever prevention policy is tied to that new group.
And if they didn't configure the prevention policy on that new group?
If that new group defaults to a less restrictive malware policy or even a different sensor update schedule that causes the server to reboot during peak trading hours, the network specialist has inadvertently caused a massive outage or a security breach.
Just by trying to fix a firewall issue?
Exactly. So it's a hard-coded separation of duties. It's a built-in safety net.
That makes so much sense. The network specialist, the firewall manager, they define the logic of the network traffic rules. But the Falcon administrator, who has that holistic view of the entire enterprise risk profile, they define which endpoints those rules apply to by controlling the host groups.
That is exactly it, and the CCFA exam will test this explicitly, I guarantee it.
So if a question asks how a firewall manager should apply a new rule to a completely unmanaged set of endpoints,
the answer will always involve coordination with the Falcon administrator to handle the underlying host group infrastructure.
Got it.
Furthermore, you need to remember that standard SOC roles, like security leads, investigators, analysts, they are strictly limited to viewing firewall rules and audit logs. They absolutely cannot edit them.
Okay, that makes the separation of duties incredibly clear. Now, identity protection is another module where the roles fragment pretty significantly. To manage IDP, we're looking at two roles, the Identity Protection Administrator and the Identity Protection Policy Manager.
Right, because identity protection fundamentally shifts the focus from the endpoint to the credential. and the RBAC architecture has to reflect that shift.
So what's the difference between the two?
The Identity Protection Policy Manager has the authority to edit the actual policy rules. They define the conditional logic, the triggers, and the actions.
Like if a user logs in from an anomalous IP address.
Exactly. The policy dictates whether to block the authentication entirely, enforce multi-factor authentication, or maybe simply log the event for review.
But a standard investigator or a Falcon security lead cannot touch those policies.
They cannot. They only have access to the policy analytics page. They can view the rule audit log, but that's it.
I see the logic there, but let's pressure test this in a real incident response scenario.
Okay, let's do it.
An investigator is actively tracking a lateral movement campaign. They see a compromised credential being used across multiple hosts right now. If they don't have the Identity Protection Policy Manager role, they can't dynamically adjust the authentication policies to lock down that credential in real time within the Falcon console.
Right.
Doesn't that significantly slow down the response during a firefight?
It creates a procedural friction, yes, absolutely. But it is entirely intentional.
Why?
Because rewriting corporate authentication rules on the fly during a firefight can lead to catastrophic denial of service events if it's poorly scoped.
Oh, because they might block the wrong thing.
Exactly. You might isolate the attacker, sure, but you also might inadvertently lock out the entire incident response team or sever critical Active Directory sync processes.
Wow.
The platform restricts policy modification to specialized roles to ensure that identity-based remediation is handled by identity specialists, not generalist threat hunters.
So the investigator's job is to uncover the compromise.
Uncover it, document it, alert on it. And the identity administrator's job is to quarantine the identity systematically without breaking the business.
That is a great way to think about it for the exam. Let's shift from human response to machine speed response. Fusion SOR. Security orchestration, automation, and response.
My favorite topic.
It's so powerful. It's the ability to build workflows that execute actions automatically based on triggers. Now, the documentation notes that creating and managing workflows requires the workflow author role or the Falcon administrator role.
Right. Workflows are essentially just logical pipelines.
Yeah.
If X happens, do Y.
So the trigger could be, say, a critical vulnerability detection.
Yep. And the action could be pushing a webhook to ServiceNow to generate a ticket, sending a Slack notification to the SOC channel, or even executing a containment protocol on an endpoint.
Okay, here is the nuance that will definitely be on the exam. I know it.
Let's hear it.
If I am building a Fusion SR workflow, and my desired action is to automatically run a custom real-time response script when a specific malware signature is detected.
Okay, an automated custom RTR script.
Right. The documentation specifically states that the workflow author role is insufficient for this. I specifically need the RTR administrator role to add custom scripts to a workflow.
And why do you think that specific restriction exists in the platform?
Well, because a custom RTR script is arbitrary code execution.
Yes, exists.
It's not a safe, prepackaged CrowdStrike command. It's a PowerShell or a Bash script written by someone internally, and it's executing with system-level privileges on a remote machine.
You nailed it. If a standard workflow author had the ability to attach any custom script to an automated trigger, they could theoretically bypass the entire enterprise change management process.
That's terrifying.
It is. They could upload a malicious script, set a trivial trigger, like, trigger on any informational alert, and have the Falcon platform itself deploy malware across the entire enterprise.
It's a built-in supply chain attack, executed via your own security tool.
Exactly. The RTR administrator role is an absolute requirement here because the RTR administrator is the designated authority for vetting, approving, and managing custom scripts within the platform. The RBAC engine checks the user's permissions, not just for the workflow creation, but for the specific components embedded within the workflow.
That is so smart. It checks the payload, not just the pipeline.
Exactly.
Now, that concept of checking underlying permissions leads perfectly into data source queries. Falcon ingests an enormous amount of telemetry. Next-gen SIEM data, IT asset data, deep forensics. A Tier 1 analyst shouldn't necessarily be running complex XDR queries.
Right, because that data is incredibly sensitive. The platform silos query capabilities based on function.
So how does it break down?
To query next-gen SIEM data, you require the XDR administrator role. Querying IT telemetry, such as installed application inventories or system configurations, requires the IT administrator role. Deep forensics data requires the forensic investigator role.
So for the CCFA exam, if a scenario asks, What role is needed for a user whose sole job is to just audit installed software versions across the fleet to check for compliance?
Assigning them Falcon Administrator is the wrong answer.
Because it violates the principle of least privilege.
Correct. The correct, most restrictive answer is the IT Administrator role. You always want the tightest possible fit.
Okay, we've mapped the predefined roles and the rigid boundaries of module-specific permissions. But let's be real, enterprise environments are rarely rigid.
Never.
We have mergers, acquisitions, specialized contractor teams, geographically isolated business units. When the predefined CrowdStrike molds fail, we move into Section 3, creating roles and assigning users based on permissions.
This is where we transition from understanding predefined templates to architecting custom RBAC models. And the CCFA exam will heavily test your ability to construct custom roles.
Custom roles that provide fine-grained control over specific actions and data access.
Exactly.
So let's build a scenario. I love doing these.
All right, lay it on me.
I have a managed security service provider, an MSSP, monitoring my endpoints, but I only want them monitoring endpoints located in my European data centers due to data sovereignty regulations.
Okay, very common scenario.
Furthermore, I want them to have real-time responder access, but they should only be allowed to run the ls command to list directories and the get command to pull files.
Right, basic investigation commands.
Exactly. They absolutely should not be able to use the put command to drop files onto the hosts or run to execute processes. So predefined roles are completely useless here. An analyst doesn't have enough power, and an RTR role has way too much.
This scenario perfectly illustrates the intersection of custom roles and scoping. Those are two separate concepts that work together.
Okay, break that down for us.
First, you define the granular permissions within the custom role itself. The platform allows you to explicitly allow or block individual RTR commands.
So I go in and just check boxes.
Basically.
Yeah.
You toggle else and get to true, and you toggle put and run to false. You've now defined what the MSSP can technically do.
Okay, but the data sovereignty issue remains. With just that custom role, they still have access to my global fleet. They can run else on a server in Tokyo.
Right, and that's where scoping comes in. Scoping is the mechanism that isolates a user's access to relevant data based on host groups.
Oh, we're back to host groups.
Always back to host groups. So on the back end, you create a host group containing only the European data center servers. Then when you assign this custom MSSP role to those specific users, you scope that role assignment specifically to that European host group.
So I tie the role to the group.
Exactly. And when those MSSP analysts log into the Falcon console, the RBAC engine dynamically filters their entire view. The API endpoints that populate their dashboards will only return detection data, host telemetry, and investigation logs for endpoints whose host group ID matches their scoped assignment.
So what about the servers in Tokyo?
The rest of your global environment is cryptographically invisible to them. They don't even know it exists in the console.
That is a massive architectural control. But here is where the CCFA readiness checklist flags a really critical, often misunderstood concept: effective permissions.
Oh boy, yes. Effective permissions are where complex RBAC models either succeed or completely collapse into chaos.
Let me throw a messy administrative scenario at you to illustrate this.
Let's hear the mess.
I have an analyst who has been assigned the predefined analyst role. During a routine audit, an administrator decides this analyst shouldn't be modifying incident statuses anymore, so they hastily assign the read-only role to the user's profile, assuming that restriction will just blanket apply.
A very common mistake.
Does the read-only role act as a hard block? Does it override the analyst's permissions and lock them down?
It does not. And failing to understand this will guarantee you lose points on the exam. In the Falcon platform, permissions are fundamentally additive.
Additive, meaning they stack.
They stack. Think of it mathematically as a Boolean or OR operation. The platform compiles all the roles assigned to a user, it extracts the underlying micro-permissions from each of those roles, and merges them into a single, unified, effective permission profile.
Okay, so if role A grants the ability to change an incident status, and role B is read-only,
The system looks at the merged profile. It asks, does the user possess a permission granting status modification? Yes, they do, from role A. The read-only role does not negate or subtract that permission.
so assigning read-only to an analyst is functionally useless for restricting their access.
It is actually worse than useless because it obscures the reality of their access. It creates these overlapping, conflicting audit trails.
Because an auditor will look at it and get confused.
Exactly. When a compliance auditor reviews that user's profile, they see the read-only tag and assume restricted access, while the user continues to modify system state every day.
That is a huge exam trap. The exam will definitely test the ability to apply the absolute minimum cleanest access required. In fact, the readiness checklist explicitly mentions identifying permissions that are incompatible with Tier 1 analyst access.
Right. So if you see a multiple choice option suggesting a Tier 1 analyst requires Firewall Manager or Falcon Administrator or API client creation rights, eliminate it immediately. The exam requires you to know exactly how to audit these permission profiles to find those anomalies.
Which brings us to the actual mechanics of auditing. A user gets promoted, they move to a different department, or they leave the company entirely. How does a Falcon administrator maintain a clean RBAC model over time?
Administrative reporting is your primary tool here. The platform continuously logs RBAC modifications. You can and should query the event logs. You're specifically looking for events like user role assigned or user role deleted.
Because people forget to remove old roles.
All the time. The documentation highlights regular access audits as a core best practice. You must verify who assigned what role to whom and at what specific timestamp.
Because an overprivileged account is the ultimate target for a threat actor.
It's the jackpot.
If they compromise an analyst account, they can view alerts and, maybe close an incident to cover their tracks. But if they compromise a Falcon administrator account, the blast radius is total.
Total destruction. They can disable prevention policies globally, execute arbitrary scripts via RTR across the entire fleet, and effectively blind the organization.
Which perfectly establishes the stakes for the final, most complex section of our deep dive. Up to this point, we have analyzed the blast radius of human users. But human operations represent only a fraction of the activity within a mature Falcon deployment.
A tiny fraction, honestly.
Right. Section 4, Managing API Keys and Clients. We are moving out of the graphical user interface entirely and into the realm of programmatic access, automation, and machine-to-machine integration.
And the exam requires you to treat these machine identities with the exact same architectural rigor as human users. Actually, maybe even more rigor.
Let's establish the technical baseline first. Falcon relies on OAuth 2 API clients. We are talking about a RESTful API architecture.
Yep, standard REST API.
If an organization wants to integrate a third-party security tool, or if their internal engineering team wants to write, a Python script using FalconPy to automate host containment, they cannot use a human username and password.
They absolutely cannot. They must use an API client.
And the CCFA exam expects you to know the exact navigational path to provision 1 in the console.
Yes, navigation questions are very common.
So, to create an API client in the console, you navigate to the main menu, proceed to Support and Resources, and select API Clients and Keys. From there, you initiate Create API Client.
I'll repeat that for everyone taking notes. Support and Resources, API Clients and Keys. Memorize that hierarchy.
But provisioning the client is just the very first step. You have to define its access, and you don't assign predefined human roles to machines. You don't give a script the analyst role.
No, you assign API scopes.
Scopes.
All right, scopes define the granular boundaries of the API client's authority. And unlike human roles, which can be this complex, messy matrix of permissions, API scopes are strictly binary within their specific domain. It's just read or write.
The documentation highlights specific scopes that carry immense risk. Let's look at the host scope as an example.
Okay, a host scope.
If I grant an API client read access to the host scope, a script can pull a list of all endpoint names, their IP addresses, and agent versions. That's, reconnaissance data.
It's sensitive, but it's just reading data.
Right. But if I grant write access...
If you grant write access to the host scope, that programmatic client possesses the authority to hide hosts from the Falcon console entirely.
Hide them, meaning they just disappear from the UI for the human analysts.
Exactly. They vanish. If a threat actor compromises an API key with hosts write access, their absolute first action will be to script the concealment of the compromised endpoints.
Oh, wow.
The endpoints are still infected, they're still beaconing out, but the SOC is completely blind to them because the API key told the console not to display them.
That is terrifying. Let's escalate that even further. What about the host groups scope?
Oh, this one is worse. Granting write access to host groups allows an API client to create, modify, or delete host groups.
And we've already established that host groups dictate prevention policies.
Exactly. So an automated script could theoretically move the entire enterprise fleet, 50,000 machines, into a dummy host group with absolutely no prevention policies assigned in seconds.
And the prevention policy scope itself. Write access there means a machine can alter the fundamental malware prevention logic of the sensor. It can just turn off next-gen antivirus capabilities.
This is why scoping API clients is arguably the most critical task a Falcon administrator performs.
It's life or death for the network.
It really is. You must ruthlessly enforce least privilege. If an integration only needs to ingest alert data into a SIM, you grant it read access to the detection scope and absolutely nothing else.
The exam focuses really heavily on the life cycle of these API credentials, too. When you create the client, the platform generates the OAuth 2 parameters. You get a client ID, a base URL corresponding to your specific CrowdStrike cloud environment, and a client secret.
The client secret. That is the linchpin of the whole authentication process. And the CCFA exam will definitely test the golden rule of the client secret.
The golden rule. The client secret is displayed exactly once.
Upon creation, and only upon creation, the console displays the alphanumeric string. If you dismiss that dialog box, or you navigate to another page, or even just accidentally refresh your browser,
It's gone.
that specific client secret is cryptographically unrecoverable.
There is no view secret button you can click later.
None. Zero. The platform hashes the secret immediately after creation. It does not store it anywhere in plain text.
So if a DevOps engineer loses the secret, or if say, the enterprise password vault it was stored in gets corrupted, the documentation dictates that you must regenerate a brand new secret for that API client.
Which instantly invalidates the old secret.
And that breaks things.
It breaks everything. It immediately breaks any scripts, any integrations, or automated workflows that were relying on it. You have to go and manually update the credentials across your entire pipeline.
Let's ground this in a real-world integration scenario that's actually mentioned in the sources. An organization uses Netskope, which is a cloud security platform, and they want Netskope to ingest CrowdStrike intelligence, specifically cloud indicators of attack, or IOAs, and indicators of misconfiguration, IOMs.
It's a great integration.
Yeah.
So to architect this, the Falcon administrator must create an API client, assign it the appropriate read scopes, such as the CSPM registration scope, and securely transfer the client ID and client secret to the Netskope platform.
But how exactly do those two systems communicate using those credentials? Like, what is the actual mechanism? Because the documentation outlines the OAuth 2 token exchange process, and I think people gloss over this.
They do, and it's highly testable. So Netskope doesn't just send the client ID in secret with every single request for data. That would expose the core credentials continuously over the network.
Right, that's bad practice.
Instead, Netskope initiates a POST request to the Falcon OAuth 2 token endpoint, and it passes the client ID and secret in that initial payload. If the credentials are valid, Falcon authenticates the request and responds with a short-lived bearer token.
A bearer token. And that token lifespan is highly testable. The FalconPy documentation specifies that standard OAuth 2 access tokens have a lifespan of exactly 30 minutes.
30 minutes. No more, no less. Netskope uses that temporary bearer token in the authorization header of its subsequent API calls to actually pull the IOAs and IOMs.
And when the timer runs out?
Once those 30 minutes expire, the token is mathematically useless. The Falcon API will just return a 401 unauthorized error.
So the integration just stops working.
Well, no, Netskope is designed to handle this. It must seamlessly re-authenticate with the OAuth 2 token endpoint, using its client ID and secret again, to receive a fresh 30-minute token. It's a continuous cycle.
Why 30 minutes, though? Why not, 24 hours to reduce all that authentication overhead?
It's an aggressive mitigation against credential theft. If a threat actor manages to intercept a bearer token in transit or somehow extract it from memory on a compromised server, they only have a maximum 30-minute window to exploit it before the access automatically terminates.
That significantly shrinks the attack window. And crucially, the Falcon administrator has the capability to actively revoke an active token before the 30-minute timer expires, right? Like if anomalous activity is detected.
Yes, you can instantly invalidate the token via the API or the console, which severs the connection immediately.
Okay, that covers the token exchange. Furthermore, we really need to address rate limiting because the exam definitely tests your understanding of API constraints.
Oh, absolutely. HTTP 429 errors. Too many requests.
Because machine speed automation can easily overwhelm an API endpoint if it's not written well.
Very easily. If an integration attempts to pull millions of records simultaneously without implementing proper pagination or without respecting the platform's rate limits, Falcon will just start returning 429 errors.
It'll just throttle them.
Exactly.
Right.
A CCFA candidate needs to understand that API architecture requires programmatic back-off logic. It's not just about having the right keys. It's about understanding the operational physics of the platform. You can't just spam the API.
I want to look at the blast radius comparison between human and machine access one more time because it's such a profound difference. We talked earlier about a human administrator making a mistake with a host group.
Right, dropping a server in the wrong bucket.
Yeah. The human is constrained by their physical interface, right?
Hmm.
Mouse clicks, screen loads, their own cognitive processing speed. If a human administrator goes rogue or gets compromised, the SOC might detect the anomalous behavior and intervene before the damage is total.
It takes time for a human to click through all those menus. But an API client operates without physical friction.
Exactly. If a poorly coded Python script, armed with a valid 30-minute token and write access to host groups and prevention policies, enters a runaway loop, it can execute hundreds of destructive API calls per second.
It can obliterate the organizational structure, detach all prevention policies, and leave a global enterprise completely defenseless in the time it takes a human analyst to blink.
The SOC wouldn't even know what hit them.
The telemetry hitting the SOC dashboard would just be a solid wall of simultaneous critical alerts. And by the time a human even comprehends the scope of the event, the automated execution is already complete. It's over.
Which makes API client scoping not merely a compliance checkbox for the CCFA exam, but an absolute existential imperative for the enterprise. You, the administrator, are the architect defining the blast radius of automation.
Is the ultimate test of administrative maturity. Honestly, it's what separates a junior admin from a senior architect.
Okay, we have thoroughly dissected the user management domain today. For the CCFA candidate listening, let's crystallize this deep dive into 3 absolute, non-negotiable architectural truths to take into the exam.
I like it. Let's summarize. First, memorize the strict boundaries of module-specific roles and their inherent separation of duties.
Right.
A firewall manager defines the logic of a network rule, but they are architecturally barred from managing the host groups that apply those rules. You must involve a Falcon administrator to alter the endpoint organizational structure. Do not fall for that trap on the test.
Perfect. Second, understand the mechanics of effective permissions. In the Falcon platform, permissions are additive. They utilize Boolean or OR logic.
They stack.
They stack. Stacking a read-only role onto an analyst role does not restrict the analyst's ability to modify state. It merely creates a convoluted audit trail that violates administrative hygiene. You must default to the principle of least privilege natively, not attempt to enforce it retroactively with conflicting roles.
Exactly. And third, treat API clients as highly volatile machine identities. Scope their access with extreme prejudice, understanding that a single write permission can weaponize an automated script.
And the lifecycle.
And never forget the lifecycle mechanics. The client secret is generated and displayed exactly once. If it is lost, it is unrecoverable, and you must architect a complete credential rotation.
The architecture of access control, it's fascinating. But before we conclude, the documentation actually hints at an evolution in this architecture that fundamentally changes the nature of this entire conversation.
Oh, you're talking about the AI integration?
Yes, we've spent this entire deep dive analyzing the control of human operators and deterministic API scripts. But the platform is now integrating Charlotte AI and agentic security models.
It's a huge shift. Charlotte AI translates complex data interactions into natural language queries, which is cool, but the concept of agentic SOR is far more profound.
Right. The sources describe empowering defenders with AI that can automatically generate workflows, pull dashboards, and execute actions based on high-level goals rather than explicit programmatic instructions.
Find the threat and contain it, rather than run this specific script on this specific host.
Exactly. We are shifting from declarative automation, where a human writes a specific Python script to execute a specific API call, to agentic automation, where an AI determines the necessary steps to achieve an objective on its own.
And that forces us to question how a static RBAC model governs a dynamic decision-making entity. It breaks the current paradigm.
It really does. As you prepare for your CCFA exam, consider this. How will the definition of user management change when the primary user operating within your environment is an autonomous AI agent?
Right, like when an AI generates a workflow on the fly, how do you audit its effective permissions?
Will future Falcon administrators require entirely new classes of roles specifically designed to bound the reasoning capabilities of artificial intelligence?
Do you assign an AI read-only access, or do you actually have to define the ethical and operational boundaries of what it is allowed to infer from that read-only data? It's wild to think about.
You are no longer just managing access to a digital vault. You are governing the logic of an artificial operator moving through the infrastructure at machine speed. Passing the CCFA exam requires you to master the deterministic rules of today, but truly securing the enterprise requires you to anticipate the agentic architecture of tomorrow. You have to deeply understand how the lock works before you can safely hand the key to an AI. Good luck on the exam. You've got this.